So now we've got the experiment set up. We've got the hopefully understanding how to read a vernier scale, so you can always ask me in the lab if you have trouble. So we're going to do the first part of the experiment now. So it's quite straightforward what we're going to do. Basically, the eyepiece is centered at the moment, so it's right in the middle of the ring system. So that doesn't matter for the technique that we're going to use. And what I'm going to do is I'm going to dial it all the way to the left. So I'm going to count every 2 rings going to the left for 20 rings. So that'll be about 10 readings that way. And then I'm going to switch, go back to the center, and then do 20 rings the other way as well, taking a reading every 2 rings. And then, of course, if we take the difference in the position, that should give us the diameter of the ring. So the first part of this experiment, the equation's given to you in the text, but it's y squared equals mr lambda over n, where n is the refractive index, r is the radius of curvature, lambda is the wavelength of the light, and m is the order of the ring. So effectively we're going to relate the radius, so we're going to calculate the diameter, and then hopefully I won't have to tell anyone how to convert that to a radius, but we're going to use that to figure out the radius of curvature of the lens, because of course everything else we know. N is 1 because it's air. Lambda is specified, the wavelength of the light source used is specified in the text, but it's a sodium lamp, so we know what wavelength it produces. And we should be good. So I'm going to stop talking now. I'm going to take the readings. There'll be a bunch of photographs on the next few slides, and you should be able to take the data from them. See you in a bit.